Okay, now let's just talk about entity component system. This is the most important part. If once we understand how the entity component system works, then most of the Gazebo systems plugin will be able to understand much easily. So it's very important that we try and to understand this. And I will use an intuitive approach to make you understand. We'll try and understand entire entity component system using an example. Okay, so let's see. So these are just three part: entity, component, and then system. So for example, what are there an entity? Let's take Gazebo as an example. So see, world is there in the entity, model is there in the entity, link is there in the entity, light, sensor, all these are entities. But what is actually entity? You'll be shocked to see this. Even I thought that entity would do something else, but entity is basically nothing, just an integer value that's assigned to this. So this is just an integer value that is being assigned to this. So model, for example, model will have like value like 4, and if there is model number 2, if there is different model, then it will have value 8 or some other thing based on the sequence and all those things. But the thing is, it is just for identity, and it is represented by just numbers, nothing else. So this is interesting. And next, then what is component? So component, for example, this is a component: name, pose, size, static, velocity. All these are component. Not just this, there are many others. I've just taken this as an example to make you understand. But the interesting thing on this as well is, see this. So what happens is they actually world has these components. How? For example, this component can be used for this world as well, and it can be used for this model as well. It can be used for this because it's just name, right? So even world will have a name, even model will have a link. So see how different this is from OS, that here you can easily, using component, you can use the same component to define many other things. Not just this, even like for example, you have world number 1, you have world number 2, like world number 1, world number 2, they can have name component, they can have name component, they can have pose component, they can have, so you can add the component, you can create the component, also you can delete the component on the runtime. So that's what makes this style very efficient, and you can attach them anywhere you want on the runtime. For example, if you want to attach light with a size, you can attach that. If you want to make static change on the world, you can attach that. For example, it may happen that it might not have anything attached to it at the runtime, like it may not have nothing attached to it, like nothing is there, then you just add this pose to this world, or you add this model pose to model, or you add a linear velocity to this. So it can be like, it's very much open ended, and it's very much properly distributed, and you can easily use this using component to make worlds. And this kind of architecture is very much open to have anything as a component, and you can directly use it. Okay, so this is one major benefit of it. And then what is component? Component is nothing but a data structure. So it can be any data structure. See, it can be any data structure. It's not just one. It can be name, it can be A, it can be M, it can be E, it can be anything. So for example, if you have this velocity, it can be velocity in X, velocity in Y, velocity in Z. For example, if you have this pose, then X, Y, Z, roll, pitch, yaw. So it can be anything. Like static, it can be just a true or false value. So it is just a data structure, it's nothing more. So what actually how it looks like is like a model has a name component with some values, and this for example will have some value, and then this pose will have some list of values, and this all are component. This is entity and this is component. Okay, so I hope entity and component relation are clear to you. Now what is system? System is more interesting. Like, it just reads and write on the component. It's nothing to do with this entity. What they do is they read or they write on the component. So for example, like if you have model 1, it might have a name, and then a model 2, it might also have a name. Then if you want to read a name, then you will find this identity entity like 1, and then this entity that's, let's say it's 2, and then you will use to read, you'll use system to read this component. So entity helps you to find that component, and then component helps you to read or write on the component using system. So this is what the entity component system is actually. I hope now concepts are a bit more clear to you. Also, let's understand with an example. For example, we have this box that at time 0 it's 0 and x0 is 0. It's moving with 1 meter per second. Then at time 2, it will at 2 seconds it moves 1 meter. Then same example at time 3, it will be 3, right? 0 1 2 3, this will be 3. So it would be 3 and x distance will be 2 meters. So how this actually happens? So for example, we have this entity that's have this value at 2. So basically the entity is nothing but 2. And then we have some components that attach to it. For example, those components can be names or some others. For example, we have name as box, we have pose as this 6 values that x, y, z, and then this is roll pitch yaw. Same this, because this box is moving, this is not static, and then linear velocity around x is 1. So I haven't mentioned all the other values x, y, z, and roll pitch yaw, but it's moving with linear velocity of 1 meter per second in x direction. So this all what container have. Now for system to actually move this box from here to here, what system actually does is every second it just changes the box. What it changes? It changes the box pose, right? So what happens when at 0 this pose is 0? So x is 0. So at time 0 it's 0. So every second it keeps on changing the box. What it keeps on changing this component. It keeps on changing this component. So at this, because it's moving with 1 meter per second, so 0 1 2 3 like this it will move. Okay, oh, sorry for the mistake. This will be 1 and this will be 2. So what happens at 0 second, this pose, the pose is 0 0 0. Then on 1 second this x position moved 1 meter, and then on 2 second it moved 2 meters because it's moving with 1 meter per second, right? So every second it's moving 1 meters, right? So this is how the system works. System just acts on this component. System just acts on the component. Which component is this? This uses pose. And how it get to know whose pose you have to edit? Using this entity ID. This is 2, right? Using this value, it came to know that where I will find this component, and what system did. It just updated this pose. It just updated the container. So that's what's the meaning of system interacting with container. What is just, it just changes the component based on the time and other factors. I'm using this as just an example to make you understand how this entire thing works. What is actually is interacting with the component. Now I hope this interacting with the system is just interact with the component line is clear. Even in the architecture we saw the same thing, right? Physics is interacting with the component. So even physics does the same thing. So it interacts with the component and it changes the velocity, poses, and all those things. And then rendering use this pose. It reads this value and renders the change in position every second. Okay, so I hope now these concepts are more clear, like how entity component system is, how other things interact with that, and how component and system interacts and make this entire system work. So now let me show you how this actually looks in Gazebo. Okay, so we'll docker execute -it. Okay, our container is not running. We need to start the container. Now let's go inside the container, bash. Okay, one more thing we need to do. We need to give it a host access so that we can see this. Now in this, we just start Gazebo Sim, and maybe let me go into some world and show you, that would be better. For example, I come inside this world and then I do Gazebo Sim. Let's use this world. Let's use this SDF file and let's launch this up. Okay, this is fine. The one thing that I want you to understand from here, see this model, this is the model, this is entity, right? And it has got value, and the parent entity, what is the parent entity of this? This will be world, right? So the parent entity is world and the child entity, that's model, is 4. And then we have this different component attached to this pose, then this wind, then this, and then this self collision. And it's same for every other model. If you see, I can show you. So for example, if we go inside this, it has link, then it has this link, then this all are component, then this link entity is 5, this value of this link is 5, and parent is 4. Who is the parent? This is 4, right? So this value of it is 4, and this is child, and this is 5. So this same goes with, and this has this entity parent, and this has this pose, right? So see this XYZ pose. Same goes with this cube model that you're seeing over here. This has this parent as 1, so world was 1, right? And the entity value is 8, and it has this pose component. This is a component. This entire thing is a component. Even same, this is also a component. So this is a component. This is also, this all are also components. This is component. This all are also component, and this is entity, and this is also component. This is also component, and this component has value 1. So this component have all these values, right? So this is how entire system is. So everything that you see on this tree, this is also written, see this entity tree. So everything on this is just entities that we just saw in the presentation, and all of this that you're seeing over here, this all are components. Now I hope everything is very much clear to you. Now I hope you understood this, every of this thing very much clearly. If not, just rewatch this video, because this is very important, and this is the building block of entire Gazebo Sim. And this is how every plugin is written around it, around entity component system. Okay, now let's get back to this entity component system. And as I was saying, entity component system was firstly being started, it's an architecture. Okay, so it's being firstly started using very much in game engines. So game engine, I started adopting this entity component system a lot firstly. Then from game engines, because of this modularity and other things, Gazebo Sim has recently started using this. So Classic never had this. Classic had this ops thing, but now we have this entity component system as an entire architecture around it. Okay, so entity component system also does a very good benefit of caching things. Let's understand what that means is, so there are two parts if you know normal computer things. So one is this CPU and the other part is memory. So every thing that CPU has to perform, every function that CPU has to perform, every task that CPU has to perform, it uses a memory to perform it. But the problem is that so CPU is very fast at math but very slow at memory accessing. So it's very slow at taking up the memory from RAM. So this is RAM. So it's very slow at taking memory from RAM. For example, if you see this diagram, you'll see here CPU has this, and then CPU has its own caching. Those are called L1, L2. So caching is basically short memory that CPU holds inside it. So this is L1, L2, L3. So these are of different size. And so if you see the CPU registration on operation, this how latency is, how fast it can access. In 1 cycle it can access, in 4 cycle, in 12 cycle. But see the RAM is pretty slow. Like it runs at 200, 400 cycles. It's very, very slow. It's very slow relative to all of this. So what CPU does, it instead of pulling everything from the RAM, okay, instead of pulling everything from it uses this caching to maintain its memory. So it has small caching size. So if your code is not pulling anything from this RAM, directly using this caching, by default your system will run faster, because it doesn't have to wait for the memory, it doesn't have to access the memory from RAM. Directly it will use this caching and make it work. So even ECS helps us in maintaining that caching very well. We'll understand why. Let's understand why. So if you see what's the problem with OOP is, so the problem with OOP is that, so this is a class, in this you have this standard string, but the string is, it's a dynamic memory. There's very famously called heap memories, because they are allocated on the runtime. So this is why it is allocated on the runtime. Same goes with this vector. It's a long vector, right? So it's also allocated as a heap memory, dynamic memory on runtime. Okay, so these all are allocated on runtime. And then this size is static. These are all static. This static because on the compile time their size is being fixed. But because the name can change, for example, you can have A and then maybe you can have this same ABC. So this is size 1, but this is size 3. I'm saying character wise. So that's why this size keeps on changing, right? So because of that, it dynamically allocated on the runtime. So if you have two objects, then you will see that happening. So what actually happens with this, we'll understand in the next slide. But if you want to know more about on heaps and dynamic memory allocation and how this works, you can check this video out. And what happens because of that, because we have two objects, right? We had this two, model has these two objects. So I'm taking those as an example to explain you what happens when you're accessing this model name and when you're accessing this pose. What happens, this, because this size can be different, right? So for example, this has size of 3, but the next object might have a size of 4, and because of some technical thing, because the size are different, many of the times it leaves a discontinuous memory in the middle. Same goes with the pose also, it's of 2 size and this is of size 3, so it leaves a lot more memory in the middle. This I'm talking about the RAM memory. And also this, because these are discontinuous memories, and how it happens, it use model then model to this, and because the size difference causes this issue of discontinuous memories. So you can learn about discontinuous memory in details, but I'm telling you more from an intuitive perspective so that you understand it much better. And this discontinuous memory is the main problem that causes even caching to not perform, because there are gaps within width and caching has to keeps on increasing its size, and it can't store everything on the caching. So the better way to do is, what entity has, we already understood the entity. What actually entity does it, in entity case we do not have this sort of arrangement, right? In entity case we make all of this as an component. So if you see this model 1 and model 2 are the have become the entity, but these are the component. And the main magic is, because we are dealing with same sizes in the sense they are continuous, one by one they are allocated. Because of that, it becomes a continuous. So what actually happens, what actually happens is, so this model, so it first goes on model number, it doesn't go like model number 1, then it reads this, this is on oops, this is oops style of reading. It goes like this and then it's read this, and obviously this is of different data structure and this different size. You will have spaces left be in the middle. But how entity works, it doesn't care about this entity anymore. So what happens in ECS is that in ECS we do not care about this model anymore. We directly go like this. We read one component, this both are component, right? So this both are component, we read this model number 1, this read model number 2 model space, and then we read this continuously. This is continuous. This, so if you see this reads like this. This read this first, then this goes to this, then it goes further on. Okay, so it goes further on. Same way it reads this, then this. So these are of same type. These are of same type. Because of that, when you on a caching level, it doesn't make any gaps. It becomes a continuous because you are reading same type of component continuously. You're reading same type of component continuously. Because of that, the space is not left in the middle. There is no discontinuous memory anymore. It becomes continuous. Because of this, the caching becomes much better in ECS, and it has been seen that ECS perform much far better than OOPS method because of this caching. So this system focuses more on caching than on OOPS style of designing. So this is caching centric thing, and if you learn about more on ECS, you will understand more things in detail. But the important point I told you, the main crux I told you, the how things works and what is the benefit of having ECS. And this was firstly adapted by game engines. Now we have this for Gazebo. That's a nice thing, right? So I've covered all of this, and all of this are also written on detail on this doc. You can check this doc out as well. And I will highly recommend reading more about entity component system so that you have better understanding about how OOPS and other thing works. But we just discussed the main crux of it.